This video is prepared by Avya Classes. Please subscribe the channel, raise your doubt and watch the video for sure success in JEE, AIMS and NEET. Now we'll see one problem of JEE screening 2004. A particle moves under the influence of a force F is equal to kx in one dimension. K is positive constant and x is the distance of particle from the origin. Assume that the potential energy of the particle at the origin is zero. The schematic diagram of potential energy U as a function of x is given by. So you have to calculate the value of potential energy as a function of x. So again it is given that F is equal to kx. So as we know that the force is equal to F is equal to minus du by dx, as the potential energy is a function of x only. So from there we get minus du by dx is equal to kx and du is equal to minus kx dx. So now if we have to integrate it, then we will get the value of potential. So minus kx integration dx. So how we will integrate it? So it is given that the potential energy of particle at origin is zero. So at x is equal to 0, potential energy will be 0, and at x is equal to x, suppose the potential energy is equal to u. So in this way we will get the potential energy as a function of x. So from there we get u minus 0 is equal to minus k x square by 2 and limit is 0 to x. So we get a value equal to minus kx square by 2. So u is equal to minus kx square by 2. This is the value of potential with respect to x. So clearly if we see, then the figure for this curve will be denoted by this first, as we know that the equation of if the equation of parabola is x square is equal to 4ay, then the format of this is this one, and if the equation is of the form x square is equal to minus 4ay, then the equation will be, then the curve will be of the form this. So here the y is v. So if I put the value in this way, then it comes is equal to x square is equal to minus 4av 4au, where u is the potential energy. So clearly if you see that this equation is of the form x square is equal to minus 4ay, and the answer will be a. Now suppose instead of force kx, if k will be negative, here k is positive, so we get in this way. If k will be negative, k will be less than 0, then the potential energy u is equal to minus kx square by 2, and minus k will be positive. So in this way, if we consider k dash is equal to minus k, then the potential energy equation will be k dash is x square by 2, and in this case this will be of the form, in this way x square is equal to 4ay, so then answer will become d. So for k greater than 0, the answer will be a, and if k is less than 0, then answer will be b. So in this way we can solve this problem. Now the next problem is that the fx and corresponding ux graph are shown in figure. 3 points a, b, c in fx graph may correspond to p, q, r in the ux graph. You have to match the following, that you have to basically match that which point in the fx graph represents to their corresponding point in the ux graph. So how we will calculate it? So first, if you see this figure, then this is the point where the force will be 0, will be the point of equilibrium. So point A and C are the point of equilibrium, and we will first match these points. So for first we will consider the case of a stable equilibrium. So u, if the u is potential energy, then u minimum, or the minimum value of least, that is u minimum, corresponds to a stable equilibrium. I just note it down here, and U maximum corresponds to unstable equilibrium. Unstable equilibrium. So again, second thing is that the force is given by F is equal to du by dx. F is given by minus sign of du by dx. So for u minimum, du by dx must be equal to 0, and d2u by dx square must be greater than equal to 0. So this is the condition of minimum, that for the minimum value of u, the differentiation must be equal to 0, that is force must be equal to 0, and the double differentiation must be greater than equal to 0. And if I use this equation 1 and 2, then we get that d by dx and value of du by dx is equal to minus f must be greater than 0, or minus df by dx must be greater than 0, and df by dx must be less than 0. So if we get df by dx less than 0, then this point will be a stable equilibrium. So similarly, for df by dx greater than 0, we get the point of unstable equilibrium. So for stable equilibrium, df by dx must be less than 0. For unstable, df by dx must be greater than 0. And if you consider the neutral equilibrium, then df by dx will be equal to 0. So we will see the value in the all cases. So again, for the neutral equilibrium, potential will be constant. Potential will be constant in case of neutral equilibrium, and df by dx will be equal to 0. So we will now try to plot this thing. So if you see this figure, then at the point A, first consider the point A. If we draw a slope of the line, if I draw a slope of the line, then the line is making an angle theta, and df by dx at the point x is equal to A will be equal to tan theta, and theta is greater than 90 degree, imply that tan theta will be less than 0. So tan theta will be less than 0. So df by dx will be less than 0 at the point A, and whatever we have deduced that df by dx, for df by dx less than 0, we will have a stable equilibrium. So this corresponds to a stable equilibrium where the potential energy will be least. So this corresponds to the point R. So basically the point A corresponds to the point R in the ux curve. Similarly, if we consider the point C, then, and if we draw the line, then point C is making an angle alpha, where alpha is less than 90 degree. So tan alpha will be greater than 0, and df by dx will be greater than 0 for x is equal to B, x is equal to C. So clearly in this case, at x is equal to 0, as df by dx will be greater than 0, so it represents the unstable equilibrium. So at unstable equilibrium we have the maximum potential energy, so it will represent this point P, where the potential energy will be maximum. So A will represent the point R, and while C will represent the point P, that is A will be the point of a stable equilibrium, and C will be the point of unstable equilibrium. Ball is released from the top of a tower. The ratio of work done by force of gravity in first second, second second, and third second of the motion of ball. You have to calculate the ratio. So first we will derive the formula that what is the displacement of a ball during consecutive time intervals. like in the first second, second, and so on. So we have to calculate, suppose the ball is dropped from the height edge. However, this formula we have already derived in the motion in straight line. I just make you, or I just recall it here, that suppose if I drop a ball from some height and during t time it moves a distance equal to h. So during the time t minus 1, this is within for time t, so during the time t minus 1 it travels a distance equal to h dash. Then in the tth second, the distance traveled will be equal to h minus h dash. So we will first calculate the distance traveled by object in tth second. So h is equal to half gt square, as the formula is s is equal to ut plus half at square, and here u is equal to 0 as we are dropping the ball, and a is equal to g. So similarly h dash is equal to 1 by 2 g t minus 1 raised to power 2. So h minus h dash is equal to 1 by 2 g t square minus t minus 1 square, and from there we get 1 by 2 g t plus t minus 1 into 1. So we get 1 by 2 g into 2t minus 1. So if you take 2 common from there, then you get g into t minus 1 by 2. So now if you consider the figure, then the ball is with the gravitational force mg works on the ball, and the work done by force of gravity will be the force of gravity into the displacement, that is we just term it equal to dt, that is distance travel in time t. So mfg into dt, and it is equal to mg into g t minus 1 by 2. So it's equal to mg square t minus 1 by 2. So clearly and this is the work done in th second. Work done in th second is equal to mg square t minus 1 by 2. So work done by gravity, force of gravity in th second is directly proportional to t minus 1 by 2. So now we will calculate work done by gravity in first second, and it is equal to k, where k is some arbitrary constant. So k into 1 by 2. Similarly w2 is equal to k into, not arbitrary constant, we can calculate the value of k is equal to mg square. So w2 is equal to k into 3 by 2, and similarly w3 is equal to k into 5 by 2, and so on. So if I take the ratio, then w1 ratio w2 ratio w3 and so on is equal to 1 is to 3 is to 5 is to 7, and so on. So clearly the ratio of work done by force of gravity in first second, second second, and third second of the motion of ball will be in the 1 is to 3 is to 5. See, last problem, a body of mass 2 kg is moved from point A to point B by an external agent in a conservative field. If the velocity of body at point A and B are 5 meter per second and 3 meter per second respectively, and the work done by external agent is minus 10 joule, then the change in potential energy between point A and B. So this is our figure, that suppose that we have some external field here, and the object is moving in this conservative field, such that there are 2 points A and B, and the velocity at this point is 5 meter per second. Here velocity is 3 meter per second, and the external force F is acting, which does some work. The value of work is minus 10 joule, and you have to calculate the change in potential energy. So exactly, as per the work energy theorem, the work done is equal to change in kinetic energy. So the work done is composed of two parts. First is the work done by external. work done by external force, we denote it by EF. So work done by external force plus work done by the conservative field, and this work done by the conservative field or against the conservative field will increase the potential energy, or will either decrease the potential energy or increase the potential. So it will basically change the potential energy. So we just write it WEF plus change in potential energy is equal to change in kinetic energy, and it is equal to half m VF square minus VI square, and VF is final velocity is 3 meter per second, so 3 square minus 5 square. So value of m is 2 kg, so 1 by 2 into 2, 9 minus 25, so the value comes equal to minus 16. So the work done by external agent is minus 10 joule, so minus 10 joule plus delta U is equal to minus 16, and we get delta U is equal to minus 6 joule. So clearly the change in potential energy will be equal to minus 6 joule, and we have to basically the potential energy decreases. So if you have to consider the change, then change is equal to 6 joule, and it's decreasing the potential energy. So what is the meaning of decrease in potential energy? It means the particle moves in the direction of conservative field. So if we consider the direction of conservative field, conservative field is from A to B, then we get the true picture, that is change in potential energy will be equal to 6 joule, and answer will be A. If you have any issue that how we can visualize this thing, then you just draw the figure with respect to gravity. Like if I take the object at the point A and move it to the next point B, which the point B is lower than the point A, and the external agent is doing the external agent is doing some work. So if the external agent work in the upper direction, then so if the external agent is doing, the force is applied in the upward direction and body moves in the downward direction, then we get the value of work done by external agent in with a negative sign, as the force and displacement both are in the opposite direction. So clearly the external force will act in the opposite direction, and the object will move in the direction of conservative field. Here the conservative field is the mg, and which acts in the downward direction. So because of this gravity or this conservative field, as the particle moves along the conservative field, so its potential energy decreases. So we can also change the value of F here from this to this way. So F is in this way, and particle is moving from A to B in this direction. So answer will be A 6 joule.